Hi class, welcome again to another session on rehabilitation engineering. Today we shall discuss balance training. So we all know and understand the importance of balance. Otherwise, without balance, I wouldn't be sitting in front of this computer and, discussing balance training. So any activity we do in our day-to-day lives, we do require balancing, quite a lot of balancing. Because every time we stand or walk or sit, we are defying the effects of gravity. In the sense that when you are standing and if you are not balanced properly, then you are bound to fall down, either backwards or forwards, because there's always a gravitational pull. Now, all this gravitational pull is, nullified by an equal and opposite force that the muscles of our body exhibit, and that's the reason why we are able to maintain a posture. Now the term posture, what does that mean? Now, it is the term that is used to describe the position of a human body. Now, posture can be someone lying supine or lying prone or sitting upright or slacking, standing erect or standing with more weight on one leg and so on. So this is just ways of describing how a human body is positioned in the three-dimensional space. The balance is dependent on the input from sense organs as well, the vestibular apparatus and the proprioceptors. So all the inputs from the sense organs, which are your eyes, your ears, and then your nose, and then your skin, and all these sense organs, the input from all these sense organs, along with the vestibular apparatus, which is the inner ear, and the proprioceptors, all these inputs are amalgamated together in the brain, and ultimately that results in the posture, the balance, and the equilibrium. Now, balance can be of two types, static and dynamic. So if you are stationary, if you're not moving, then that is static balance, and if you're on the move, then the muscles which acts to maintain your position while you're moving is called as dynamic balance. Now, static balance is like the rigid stability of one part of the body over the other. Now, for example, I'm seated in a chair at the moment. So my body is balancing on a chair that is stationary, and that is, balancing on the ground. So of course, chair is non-living, so you need to have additional, quite a lot of support around the chair to, make it stand still. Otherwise, the chair would fall. If, a wobbly chair is more likely to fall down over a stable chair. Now, I, on the other hand, have muscles that are defying the effects of gravity, which is allowing me to sit erect. I'm not falling back, or at least you'd have to believe that I'm not falling back at the moment. So I can, any human being can voluntarily maintain a particular position for a certain duration of time. And that is defying the effect of gravity and maintaining balance. So if you're immobile, then, that you're balancing and you're immobile, then that is called static balance. The head control of a newborn baby is a gradual procedure where the neck muscles and the spinal muscles, they strengthen, and that results in the stabilization of the head. So again, the head is balancing a lot, it's requiring, it is getting it gets gravitational pull from all directions, and the muscles on your neck and your spinal column are actually responsible for holding your head in its position. Now, dynamic balance is, like I said, maintaining the posture and equilibrium while doing activities such as running, and then swimming, because you're like floating in the water, you're not drowning, right? So all that is the effect of balancing, and that is dynamic. Anytime you're mobile and you're still able to maintain your posture, then that is dynamic balance. Now, equilibrium reactions are actually the forces that the body is automatically opposing in order to maintain balance. So our body's automatic response to reduce the effect of destabilization and demobilization assists in the maintenance of equilibrium. So every time in three-dimensional forces, so it's three-dimensional space, there are infinite number of forces that are acting on our body, and our body is countering these forces in order for us to maintain our position. Now, methods of stimulation, like for a patient who is having issues with their balance, there are various methods of stimulation. So for example, the balance to improve in a particular position, a patient must be assisted to withhold that position. So initially, if the patient is having issues in balancing while they're seated, then the chair should be provided adequate support so that they're able to hold their position. Now, again, a man's natural orientation is in its vertical axis, and he or she needs assistance in moving in that axis because we are used to sitting upright. We are not used to lying supine all the time, right? So we would require assistance while we are erect. We are not when we are not supine, because when we are supine, our body is totally supported by the bed or the medium that we are lying in. An equal and opposite force should be applied to nullify the effect of gravity and maintain a set position, which is very understandable. And alternating tapping in the trunk position will stimulate minor adjustments in a person that needs to make that is required to make their posture for maintaining balance. In order to get required posture, the trunk should be alternately stimulated from both the sides, the left and the right, and that would help in balancing a certain posture. Now, maintenance of position for people who have issues with balance, the patient is asked to maintain a particular position while the therapist attempts to displace them forwards, backwards, or laterally. So this is like resistance training. The patient has to maintain his or her position while the therapist is trying to destabilize their position. Often, objects of assistance such as the balance board, rolls made up of cardboard tubes, and therapeutic balls are used to aid in balance treatment. So you get those large balls that are therapeutic balls where people are allowed to balance. If the balance reaction fails, then protective extension of the arm is an important reaction. So if while they're losing balance, often we try to have our arms wide apart in order to have a certain sense of balancing. Then the movement of balance is stimulated smoothly and steadily over a small range of movement initially, and then the movement is increased, and then the range of movement is increased as the person gains more confidence. Lastly, too much emphasis on stability will also prevent the patient from trying, because you're making them conscious about their balance and stability. So if you just make them too conscious, then that they'll not try hard enough. They just remain in their comfortable position. They just know that this is the limit that I have and I should remain within that limit. So they wouldn't want to try harder. And if they don't try harder, then they're not going to improve. At the same time, too much stimulation will result in loss of balance, which in turn will result in loss of confidence and ultimately do damage to the patient. I think that's all I have to discuss on balancing. I hope you had a fruitful session learning about it with me. I shall see you again with more rehabilitation engineering. Thank you very much.